because you have to say to somebody, you know the world you think you're living in? Not so much, actually. You're living in a completely different world. You're going to need to start over because everything you know is wrong. That's really hard.
When you first start to get it, you're telling me I'm not processing this optical information? I'm not calculating it? When I heard that, whoa.
Yeah, absolutely.
Hold on,
It's a paradigm shift. But evolution would never have prepared us with a perceptual system that didn't do what we needed it to do.
Imagine you take a golf putt, you putt toward the hole, and you're off 2 inches to the left. What should you do the next time? The obvious answer is putt 2 inches to the right, but what does that mean to your body? And I was like,
nothing. That means nothing to your body.
Yeah.
So you are seeing using your tongue. And it takes people maybe a minute of practice and they can navigate a maze with it.
Gibson took unsolvable mysteries and turned them into scientific problems. Evolution would not have developed perceptual systems that are sensitive to units that we created.
We just invented.
Yeah.
Yeah. Because time, we invented. Space, we invented. They were conventions as a way of describing a natural universe. But why would that be what we evolved to perceive? Instead, we need to perceive, I can eat that. That thing can kill me, I should run. I can hide there. That looks like somebody I want to mate with. That's what we need to be able to perceive. Hart made this separation not because he genuinely believed there was a separation between the mind and the body. It's so that he could study the body without being, beheaded by the church. Because it's simple and it's easy, but it is also incorrect. Then we've got the unified theory of physics, right? We're going to get unified theory of psychology. All of the human behavior is explainable using these concepts. You're asking people to give up on, something that's working. It just isn't working enough, much like the geocentric view worked, but it wasn't working enough.
There's a revolution happening in science that is changing the way we understand and teach movement. And I've been working on a documentary about it. But using this new approach and reading about it wasn't enough. So I flew all the way to Norway for the International Conference on Perception and Action to meet and talk with the foremost researchers of the field in person. While there, I met Julia Blau and Jeff Wagman, two of the top minds in their field and authors of the amazing book Introduction to Ecological Psychology. In their book, they unpack the revolutionary insights of ecological psychology, both in contrast with the traditional approach and through the eyes of Fred, a cute stick figure whose story we follow as he does all sorts of activities. Unlike most scientists, Jeff and Julia have put an enormous amount of work into making science understandable, approachable, and engaging for the general public, and they've done an incredible job at it. In this interview, we'll start to unpack some of the revolutionary ideas of ecological psychology, a growing field that is changing the way we think about perception, movement, and life in general, all the way down from the foundational level of neurons, sense organs, and metal beads up to sports, robotics, global conflict, and the nature of thinking itself. Enjoy.
What is ecological psychology and why is it important? Why should people care?
Classic view of perception is that the world is out there, and then you make a copy of it in here, and the copy is bad, so you're constructing meaning. And we're like, that's nonsense for a lot of reasons. And so instead, the world is out there, and it is lawful, and it has all the information that you need to do everything you need to do. Why would we make first a bad copy and then fix it? Let's just go ahead and perceive it directly. So it breaks down a lot of the classical barriers that you run into in the classical view, and it allows for a lot more useful versions of perception, right? Because the sort of classicals tend to be focused on things like the shape of a thing or the size of a thing or the distance, where in ecological it's focused on things like, can I sit there? Could I pick up that glass if I needed to? Could I throw your book across the room? Things like that are more useful. So that's my elevator pitch.
It's a way to understand how we know and act in the world in a way that's consistent with all the other sciences. It takes those things, this act of knowing, which seems mysterious, and seems to involve lots of complicated internal processes and makes it the same thing as the processes that are active in the natural world, forming all kinds of other complicated things.
Chemistry, physics, thermodynamics.
Yes. So looking at it, it takes this, an understanding of knowing, and makes it continuous with the rest of the natural processes. And so it tries to apply the same explanatory principles that are going on in the world around us for how we know that world.
I like that.
There you go.
I like your pitch. That's a good pitch.
We both have a good pitch.
Yeah.
So I think, Jeff, you said before, I really like this quote of like, Newtonian physics and Newtonian mechanics got us to space, but it's wrong.
Sure did.
Right?
Sure did.
Yeah.
And so
Doesn't
it
mean
has
it's not
value.
good.
It's wrong. We can use it, but it has value. And Julia,
Yeah.
you said like, when we use this cognitivist approach, we hit our heads on a ceiling at a certain point,
Yes.
right? So what is that ceiling?
Well, I mean, you hit your head on the ceiling when you try and make devices based on those processes that are going to go beyond what you designed them to do, right? So we can make a robot that will clean a floor in a grocery store, right? As long as you train it on what a spill is and on how to go clean it. But that's not going to help you get a cleaning robot that will know how to clean everything, that will know how to take care of a broken glass that it's never learned how to do a broken glass before. So you hit your head on the ceiling when you try and go beyond the what I like to call a toy problem, right? Something that you've solved it just to do this one thing, and that's all it's capable of doing. And there's some deeper theoretical ways in which you hit your head on the ceiling too, and this is where we're going to go a little bit in the weeds on it. But when you suggest, as most psychology does, that there is a separation between the mind and the body, you run into some really serious problems pretty fast, right? So, for example, in that separation, we've made a distinction based on a rule. The rule is the body is physical, the mind is not, right? The mind is all the stuff that's not physical. But a physical thing can't affect a non-physical thing, right? Think about it like the ghost in the movie, right? Just discovered it's a ghost and can't pick up the glass. The non-physical thing can't pick up the glass. So how could a mind control a body if it was separate from it in that way? So we suggest instead it's all continuous. It is all one thing, and that way you don't hit your head on that particular ceiling, right? You can say, all right, instead, the mind is continuous with the body. It's all one thing. The mind is physical because everything is physical and it's all one.
The way I look at it is that the fundamental flaw with Newtonian mechanics, and not just that, but also Euclidean geometry, the fundamental flaw is that it's context independent. Those postulates of geometry and of physics are true independent of animals.
Sure.
But things like perceiving and acting are dependent on animals. And so we're trying to sort of retrofit our explanations of perceiving and acting to fit these units and these processes, and then it doesn't work. And so then we say, well, we know that these units and processes are right, so we have to put an extra step in the process to account for that. It's I'm going to borrow this example and this terminology from Andy Clark, who's a really well-known cognitive scientist and philosopher. But he says that computers are good at chess and bad at frisbee. And that's,
I like that.
yeah, and it's elegant, it's wonderful. And I think it gets at where we hit our head on the ceiling.
Sure.
We can surely build computers that can
Play chess.
beat us at chess.
You can also build a computer that'll write you an essay, but it's a terrible essay. You can't get them to write an essay without being asked. We might just sit down and write essays because we feel like it, but an AI is never going to do that, at least not the way we're currently conceiving of them. So this is what I mean. Like, you build a thing to do a specific thing, we can do that. It's when you want it to do more than that. That's where you hit your head on the ceiling. Yeah. I like that. It's bad at playing frisbee.
Good at chess, bad at frisbee.
I'm going to steal that.
what do you guys see as the strongest evidence for why we're not using that Euclidean geometry as the basis for our perception, sensation, right?
Right. I mean, you mean what is the strongest evidence that ecological is right and the other stuff is wrong?
As far as that in that particular axis,
Yeah.
right? Like, I mean, I could paraphrase the book, but I want to,
No, I mean, for me, the strongest evidence is the mind body problem. But I think there's everybody comes to it in a different way, and there's so many ways in which the other one falls short. It's hard to pick just one, you know,
Mhm.
because it does fall short when you try and actually explain human behavior. It does fall short when you try and explain why we're so bad at it. This is the other thing is that when you look at perception from that perspective, we're terrible at it. We're terrible at perceiving length. We're terrible at perceiving, mass because there's these illusions.
We're good enough that there's this sort of
Maybe we're
yeah,
just this
there's a
error.
yeah.
But 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 evolution would never have prepared us with a perceptual system that didn't do what we needed it to do. Even difflusia, which I know we've talked about here at this conference, I know we've talked about in the book. It's a single-celled organism that can build castles. So its perceptual system has to be good enough to do that job. Our perceptual system has to be good enough to do the job we do. So why are we focusing on the ways in which it falls short of things we made up? We
Yeah.
made up mass, we made up
That
length.
is the key for me.
Right?
That why evolution would not have developed perceptual systems that are sensitive to units that we created.
We created.
That
We just invented.
yeah.
Yeah, because time we invented, space we invented. They were conventions as a way of describing a natural universe. But why would that be what we evolved to perceive? Instead, we need to perceive I can eat that. That thing can kill me. I should run. I can hide there. That looks like somebody I want to mate with. That's what we need to be able to perceive, not that size is this. This is how heavy.
I have two things to say about this. So that was the evolution part was for me. That was
That's the
really the
big one.
clincher. But it was also something that Michael Turvey said when in trying to convince a class of students about this, and it has to do with movement. And this is I know something that's of an interest of yours. He said, imagine you take a golf putt, you putt toward the hole, and you're off 2 inches to the left. What should you do the next time? And the obvious answer is putt 2 inches to the right. But what does that mean to your body? And I was like,
Nothing. That means nothing to your body.
yeah, because you can't just, it doesn't work that way. You want the outcome to be 2 inches to the right, but
The first study that I did, actually, I guess the second study I did in grad school was on prism adaptation at his suggestion, and Michael's suggestion, not his suggestion, at Michael's suggestion. And the way prism adaptation works is you wear these optical lenses that shift your vision in one direction, and you're trying to throw a beanbag to a target, and that they shift your vision over here, so you throw it over here, and eventually you get better, and you throw it back on target. But I say eventually you get better, and you really have to go through the whole time in between. Because if you try that cognitive thing of, oh, well, I missed 8 inches to the left, I'm going to throw 8 inches to the right, you can do that. But if you keep throwing, you'll keep missing more and more to the right because your whole visual system is adapting and dealing with this new information. And so and then you'll have to keep, so people who try those like overtly cognitive strategies, they don't work. It's much easier to just let your visual system do what it does. And, the action perception loop takes care of all of this adaptation. And then you throw to the target where you belong.
We got to do a little.
As long as the sound comes a little after the video,
Yeah.
people will allow up to like almost a second delay.
Really?
Yeah, if the sound comes before the video, they can't tolerate even a couple of frames.
Fascinating.
In real life, we get a delay between sound and audio all the time.
Okay, so we've talked about the Euclidean geometry, right?
Mhm.
And one thing that maybe we haven't mentioned quite just yet is, okay, we're bad at perceiving like these things in these units that we've made up, right?
Yes.
To describe what we think we see.
Right.
but we're also very good at perceiving affordances.
We are excellent at perceiving affordances. We're excellent at perceiving affordances that we are brand new, right? So we can put people into brand new situations, give them an action they've never performed before, and they will figure out how to perform it rapidly. And as long as you give them consistent information, they can pick it up in almost any modality. One of my favorite things that we talk about in the book, and that as a field we talk about, are sensory substitution devices. I got a chance to check one out in his lab. So cool. But my favorite one is one where they put a little like a little sticker thing on your tongue, and it's got little metal poles that poke at your tongue, and they put a camera on your forehead, and then they blindfold you. But as you move forward, it takes the optic flow, so the movement of the video, and translates it into a flow across your tongue. So you are seeing using your tongue. And it takes people maybe a minute of practice, and they can navigate a maze with it. Yeah. And my the next favorite part about that is that then if you do this and then you put them in an fMRI and check out which part of their brain is responding to it, it's their occipital lobe, which is the visual cortex. So they're getting information from the tongue, which typically goes to a very different part of the brain, and it's going to the occipital cortex. That's going to be a problem. That's going to get picked up by the mics.
Sure. Well,
Like book a studio.
Book a studio, yeah.
Okay.
All right.
So we're good at perceiving affordances.
Yes, very good at them. Yeah.
They map from different senses in
Mhm.
certain ways.
Mapping is not a word we'd use.
Okay. Okay.
We're detecting them. We're good at detecting them, and we're good at detecting them in every way you can possibly imagine detecting them.
so long as the information is present. So the information is the pattern of stimulation that is specific to or is lawfully related to that affordance. So sometimes people will say things like, well, if we're good at perceiving affordances, then we should be able to perceive affordances all the time. Why?
Right. Why do we
would
run into a
this
glass
happen? Yeah,
door?
so why would you? Sometimes you might see someone walk into a glass sliding door, and well, why would that have happened? Well, because there's no information for that surface, right?
Yeah.
The information is that there is a pass-throughable space.
Right.
So we don't claim that that you perceive all affordances.
Right.
We only perceive affordances that there are information for, and that we are when we are attuned to that information, which comes by developing skill. So in other situations, I know that you're interested in MMA. I mean, you would be able to perceive affordances that I wouldn't because of our differing experiences. So we might be good at perceiving affordances, but we don't perceive all affordances all the time in all circumstances. It's going to depend on what we're looking for. It's going to depend on our own experiences.
And we can get better and better and better at it. And the other thing is you can sometimes perceive that an affordance is available and not be able to execute it, right? So I could perceive that you could do a cartwheel here. Just I'm not going to be able to execute that cartwheel, right? But somebody could, right? So knowing that it's available and being able to do it, two different things. So we also get better at making use of the available information. So it's not to say that we are perfect. It's just that we are way better at that than we are at perceiving these things we made up.
There's a lot of little strings I want to pull on right now.
Fair enough.
I'll see if I can remember them all in order. So first, there's a few different kind of words that I'm sure are not interchangeable,
Sure.
and yet, especially between different, and I notice you guys use them very clearly and
We're trying.
but I especially feel with, between different authors, they can almost start to feel interchangeable, and I'd love to hear from you guys
Sure.
these three different kind of closely related things, right?
Bring it.
Information,
Mm-hmm.
energy, and stimulation. How are those different?
Yeah, so energy is going to be something like light or the kinematics of vibrations in the air, which is what sound is. Stimulation is going to be the effect those things have on your stimulus organs, like your eyes or the way sunlight feels when it hits your cheek, or the way that it vibrates the inner ear. But information is going to be a lawful relationship between all of those things, right? So a lawful relationship between the energy, the space, you, and the way those things are interacting at that moment.
So this is
Not
one
ideal.
of Gibson's most important points, is that stimulation is not the same as information.
Right.
So you could, he developed this idea, or I don't know, this idea of being immersed in a fog, right? So, and it's bright. So you're just surrounded by brightness, stimulation everywhere.
But you can't see it.
Yeah, you can't see anything because there's no structure to that stimulation. Information is stimulation that is structured lawfully by the layout of surfaces in relation to a perceiver.
Right. So I'll give you an example, right? Let's say that I was walking forward and I'm looking forward as I'm walking forward. Very simple moment, right? And there's light in the room. The light is the energy. The light hitting my retina and my retina reacting is the stimulation. The information is that as I walk forward, the pattern of the flow will expand across my retina, and that expansion of that flow means that I'm walking forward. And more than that, you can discover the way you're walking forward. You can discover, you know, you can detect how tall you are, because where I am, if I'm down here and walking forward, is different than if I was up here and walking forward. You get a completely different set. So there's a lawful relationship between my movements, the action, and the way that energy is stimulating me.
And going back to an earlier point, this is the fundamental failure of the Newtonian physics and Euclidean geometry, because using those variables, there is no lawfulness. There is no lawful relation, because you're quantifying the stimulation using those variables, and it never lines up in a way where it's lawful. It always lines up in a way where it's sort of close. You're getting brightness is related to this, but not quite, which is, and then that requires these other cognitive processes to account for the difference.
Yeah.
And that's all. And so that's the fundamental failure. And that's the ecological approach's main claim, that when you look at the stimulation, the energy patterns in the right way, you reveal lawfulness.
Yes.
And therefore, all these other processes that are added on top are no longer necessary to account for the difference that would be there otherwise.
One of my favorite ways of saying this is that trying to understand perception by looking at light is a little bit like trying to understand reading by looking at the chemical composition of ink. It's not that there isn't ink there and that you can't do that. It's just sort of unrelated to the question you're asking, right? Because the question we're asking here has nothing to do with light as such. It has to do with the structure in the light. The same way that reading doesn't have anything to do with ink as such, it's the structure in the ink. That's one of
I love that one.
Thank you.
Just,
I say it a lot because I like it too.
To make one more point along these lines, that we don't even see light. We see things that are illuminated by light.
Yes.
It's the reflected light. So I think that's really, really critical in understanding what it is. The ecological approach to vision is that we don't ever see light. In fact, we would say that you cannot see light.
Right.
You only can see things that are illuminated by
this
light.
extends to all of the other things too. You can't hear sound. You hear something breaking, right? You can't feel pressure. You feel an object, right? I'm trying to do all the other senses, right? You don't taste chemicals. You taste a cookie, right? So for all of them, you're never really, it's not about the energy and it's not about the stimulation. That's just your way of detecting it. Because if it had to be about the energy and it had to be about the stimulation, then you're never going to get a story that works for difflusia. Because a difflusia doesn't have an eye and it doesn't have an ear and it doesn't have a factories, but it can build castles out of sand. That's something's going on there. Yeah.
So the other thing I noticed, maybe this is kind of already in there, but just to dig on that a little more.
Sure.
I think in the Gibsonian quotes that people refer to, it's usually like, yeah, the information in the environment is perceptually rich.
Mhm.
And I notice in your book, you guys are talking a lot more. The stimulation is fundamentally good, and it felt like you guys used a different wording that I'm sure was intentional.
Yeah, I don't think that was an intentional change. I think those things are
You can
because
the same.
well, it's not that they're the same, it's just that they're two ways of saying the same moment, right?
Right,
So
right.
information is what is stimulating. So the it's to the way we phrased it was to set it up against the contrast of the other view, right? Which is that the stimulation is bad. And we're saying no, it's good.
Right.
I think one of the reasons we stuck with stimulation was to avoid the word information, which has which is
People get
problematic.
cranky.
Yeah. So we talked about structured stimulation, which is the same as information, and we avoided the term information because it also means data, and that's completely not what we
Yeah.
mean.
Mhm.
It's also worth noting that, ecological psychology, for all intents and purposes, is a young field. So there's a lot of these things that are still up for debate, like the exact nature of affordances and the exact nature of information. We argue over the finer details a lot. That doesn't mean we don't agree on the broad strokes, and we were trying to put forward the broad strokes and to avoid some of the sticky wickets. It's good to avoid some words.
And then one more thing on that. So, is it interchangeable to say that the information is a pattern, a higher order pattern of the energy arrays that then we perceive in the simulation, or is the information a pattern in the stimulation?
I don't really see those as different. Do you see those as different?
And I would say it's in the energy. It's a higher order pattern in the energy. But, and here's the tricky part, just like we don't perceive light, we don't perceive information. We're sensitive in information. Just like in Julia's example before, you don't really perceive the expansion pattern. What you
Right.
perceive is that you're moving forward. So it's our visual systems are is sensitive to this pattern, just like our touch system is sensitive to a particular pattern of stimulation.
Right.
But what our experience is really of affordances, and we can shift our awareness around a little bit, but mostly it's at the level of affordances.
It's one of those things where it almost sounds too easy. So I run into this problem as a teacher where when I teach sensation and perception, we start with the computational view, and it's like, oh, look how hard everything is, and you have to convince them that that's what's going on because it doesn't match their lived experience at all. Right? The lived experience of perception is the everyday successes. We walk up and down a flight of stairs most of the time without difficulty. I'm not saying I don't sometimes stumble, we all do, but that's rarer than just being able to walk across the room with no difficulty. So convincing them that perception is hard, you spend a lot of time doing that, and then it turns out, oh, maybe it isn't actually so hard. So you go back to Gibson and it's like, oh no, you just see things. You just see it. And then it feels too easy to just
Yeah.
say that.
I never really thought about this until now, but the more traditional or classical approaches to perception, they have this unconscious element to it,
Yeah.
that there's this processing, and you're not aware of the processing, but it's happening,
Right.
and it's allowing you to have the rich experience that you do because the input is bad. And it
Right.
reminds me of Freudian explanations. You have this whole
Oh.
unconscious life
Yeah.
that is responsible for what's going on now. You're not aware of it, and that's a good thing. And it's just sort of operating in the background. And I think,
But then getting that to
yeah.
match your lived experience feels very strange because you're
Yeah.
like, wait, I have a whole unconscious that's happening without my awareness?
I remember being unconvinced. I had an introductory psychology professor who was trying to explain the moon illusion, which is just the idea
Yeah.
that the moon looks larger when it's on the horizon, when it's overhead. And everybody has experienced it. It really does
It really
look
does.
like that. But she was saying, oh, well, what you're doing is your brain is using these unconscious cues about you have cues to distance when it's on the horizon. When it's up in the sky, you don't have this cues to distance. It's making inferences. It's seeing it bigger. And I was just like, I don't think
That
that's right.
feels like a long way to go to
I
just
don't
say,
really-
there's a moon.
Yeah, it never
Yeah.
made any sense to me, the whole like roundabout calculation and computation. And to me, and I've had the same experience when I've tried to teach this to undergrads.
Yeah.
They're like, yeah, of course it's this way. It's like, well,
Yeah.
yeah, but
Mm-mm.
but
But hang on.
there's several hundred years
Of people saying
yeah.
no, of people saying this is hard. And I teach it a lot like Michael did, where, you spend the first third tricking them, right? Where you're like, this is what it is. And then you start kind of picking apart and doing the thing that we did historically, which is, oh, well, here's a problem with this. And oh, we hit our head on the ceiling again. And oh, we're gonna run into the loan of intelligence problem, which we explain in the book. And little by little, they start getting frustrated because students like, correct answers. They really like you to just tell them the truth, right? And I'm putting that in scare quotes on purpose. And then to come along after that and being like, psych, it's easier than that. We've got a better answer. It's like you can just see the relief wash over them. But it's true, it just feels like it's too easy this way. But that's our lived experience for a reason, because that's how we perceive.
I do wonder, though, if we need, I mean, the ecological approach at its heart is a reactionary approach. It's reacting to this, Gibson was dissatisfied with behaviorist explanations. He was dissatisfied with cognitive explanations, and he found that none of them helped him to predict real-world behavior, and so he developed this, and it would only it only emerged because of what had already existed. So we kind of have to tell the history in order to get
Yeah.
to set it up. So I wonder if that's if that's a challenge for us, that we
You got to find a way of explaining it that doesn't go through
yes,
that.
and that's
Yeah.
what I'm getting at. Maybe that's something that
We should work on.
is
I've thought this before too. It's a way to just start with ecological and not teach people about this wrong. Like, because we teach people that the sun is the center of our solar system without having to go through, for a while, we thought it went around the earth, so.
actually, that's a really great metaphor. That's what I mean when I say that Newtonian physics gets us so far. So for thousands of years, longer than that, people thought that the Earth was the center of the
Yeah.
universe because it explained a lot. It explained our lived experiences.
Yep.
Okay, well, look, and even now we talk about the sun goes up, the sun goes down.
Right, absolutely.
It
Which it does
doesn't.
not do here. It
And-
does not go down here.
Well, that's true.
Sorry.
Where we live,
Right.
the sun goes
The
up,
sun
the
goes down. Yeah.
But where was I going with
I don't
this?
know, but we should probably make it clear to the viewers that we're in Norway, and that's why. But it's just not going
In
down
high
here.
summer, mind you.
And you were
yes.
going with it. It explained all of
Yeah,
those
yeah, yeah,
things,
yeah.
but then
But it wasn't
started not
quite
didn't
right.
quite get everything.
And that's what happens in traditional approaches to perceiving.
Yeah.
It explains quite a lot. I mean, if it didn't, people wouldn't take it. They wouldn't move as far. Wouldn't have gone as far as it. But
And for as
it
long.
gets us to a point, and then it doesn't work anymore. And we, ecological psychologists, are of the opinion that you need an ecological approach to get all the way. And if
Yeah.
you take it from start to finish, you run into scientific problems,
Mhm.
but not unsolvable mysteries.
Yeah.
And that's a much
like that.
better, yeah.
Scientific problems, but not unsolvable
That-
mysteries.
Yeah, well,
Tell you,
no,
he's
no.
very
but-
smart. He's very
that-
good. There's a reason
yeah,
I work with him.
I think that's a Turveyism, though. That
Is it?
that Gibson.
Oh, so you're a
took-
good cribber then.
Yeah, well, standing on the shoulder of giants.
Aren't we?
Gibson took unsolvable mysteries and turned them into scientific problems.
Yeah, that sounds
It
right.
doesn't mean that we have all the answers, but it means that they're solvable, right? So
Which is why we need more people asking the questions with us. That's why we're trying to,
Expand the field.
expand the field. And this is what keeps happening too, is that we keep ending up talking to people who are in areas I don't think any of us would have ever thought to go and get into, like MMA would never have crossed my mind to go study MMA. But we're getting people coming and asking us those questions, or somebody who is a baseball coach, hitting coach, asking questions about how to teach people how to hit. Things would, I mean, also I just don't do a lot of sports, but things that wouldn't have occurred to me to go explore. That's why we need more people with more varied interests to come take a look. Maybe this will help you with the thing you've been hitting your head on the ceiling on. It could. It's kind of a grand unifying theory of cognition that could explain a lot of human behavior.
One thing that this is now jumping back quite a bit,
Yeah.
but just to maybe wrap that up a little bit.
Speaking of breakthroughs in understanding, I've dedicated over a decade of intensive study and practice to helping people move better and overcome injuries in every area of movement you could imagine. If you found my videos helpful and you feel like maybe you're hitting your head on the ceiling, I offer online consultations, in-person sessions, and immersive workshops to help you develop your movement and performance. And my online coaching is currently at capacity, but I might start accepting a few more people soon.
One thing you guys mentioned in the book that I hadn't seen really mentioned elsewhere is like we can perceive these, geometric Euclidean things.
Sure.
It's just they're not the predominant experience of our
Absolutely.
perception.
Yeah. There's this great paper by Runesen on smart perceptual mechanisms. And he talks about a device called the polar planimeter, right? And that what a polar planimeter does is very cool, is fully mechanically, no computations, there's no electrical components, there's no battery. You take a pointer on it and you run it around a figure, and on the little dial on it, it will tell you the area of that figure. But think about like a square, right? So to get the area of a square, you multiply length by width, right? That gives you the area of that. Our polar planimeter can't give you length and width. If you put it around the square, it'll give you the area of the square directly, but it can't give you length and width. It's not made to do that. But let's say that you asked a person who's holding a polar planimeter to give you the length of the square. And they're sitting there going, but I have this polar planimeter and it's not really made to do that. But you say, no, don't tell me any of that stuff, right? Just give me the length. Well, okay, so we can measure the area and then we go, kind of looks like a square. So we will take, the square root and then that will give me the length. And I'll be like, close, right? And the idea is that all those times that we were perceiving these other things, we were like a person with a planimeter being asked to give you length. Like we can do it, but it's not going to be great. Ask us to do what we can do, what we were made to do. We're very good.
There's a difference between can and do, and that's and I also tell students all the time, just because something does something doesn't mean that's what it's for. And we can perceive geometric shapes, yes. Is that why we have eyes? No. And so, and it reminds me of an old Chris Rock bit where he says, you can drive a car with your knees, but that doesn't make it a good idea. The rest of that bit is not safe. Is not safe for work.
Yeah.
But that part is.
That part
You
is.
can drive a car with your knees. That doesn't make it a good idea. The point is, can is not the same as do, and can is not. And just because something serves a purpose doesn't mean that's what it's for. You can tell all kinds of adaptive stories about all kinds of body parts but it might not be what you think.
Yeah.
Beautiful. I think I would say, and I think you guys would say, that the real purpose is more to perceive affordances and act, have all that coupling going on.
Sure.
Right? What are affordances?
Affordances are what the environment allows you to do in it, whether for good or for ill. I'm paraphrasing Gibson here. But they're the things you can do in an environment, and they're going to be unique to you and what you are capable of, and they're going to be unique to the environment and what's available here. Right. So for example, this table is here and I could knock it over. I could pick up your cup, I can throw it, right? There's any number of things I could do in this space. Those are affordances. Those affordances would not be the same for a dog. A dog comes in here, it's not going to be able to pick up your cup and throw it. The cup does not afford throwing for the dog because their capabilities are different. If the cup wasn't here, there would be no cup to afford throwing. Right? So it's unique to me and my body and what it does, and it's unique to this environment and what is available in this environment. So.
This is a perfect example of how, again, going back to this question about Newtonian mechanics, affordances are animal dependent. They depend on you and your geometry and your abilities. They depend on they are constantly changing.
Yeah.
As you shift your body weight, as you move around, your ability to move back changes. They change as you put on and off. You put backpack or other equipment on, you become
High
bigger. It
heels.
changes your height. Yeah, those things. They're sort of amorphous. They change shape all the time, and so that's why these units that are animal independent don't work. You can't. There are no units that can measure affordances that don't include the animal.
Yeah.
Why are affordances important?
You want to take this one?
Affordances are important because we perform everyday behaviors, and affordances are the opportunities to do so.
Yeah.
I mean, it sounds like a magic trick. When I explain it to students, it's like you perceive the future, and then I say, yeah, but it's not like that at all, right? You have to perceive an opportunity to reach for a glass of water before you reach for why would you do it otherwise? You have to be able to perceive that opportunity to engage in the behavior. It's sort of this. It's where perceiving and behaving meet, right?
It is meaning.
Yeah.
A lot of the classical views are about how do we recover meaning, right? Because we've made such a bad copy in our head, we have to recover meaning. They are meaning. They are the meaningful interface we have with the environment. The question feels to me a little bit like asking a chemist, why are molecules important? Because it's what we study, right? That's what we study. Human behavior is entirely predicated on affordances. Can't do a thing without them. So it's the thing we study, and we're trying to show how it is that we perceive them.
It also, I think, provides a way to think about perceiving that includes diffusion,
Right.
right?
Right.
Because
diffusion has affordances too.
yes, and
A different way of making contact with them than us, but
all animals, all
Yeah.
organisms have to perceive affordances.
Yep.
Every single one, all the insects, all the birds, all the mice,
yeah,
all of them have to be able to perceive opportunities that are available for them to eat, to avoid being eaten, to perform the behaviors they need to do every day. And then also in an evolutionary perspective, affordances, the ability to perceive affordances might very well be what is selected for.
Yeah.
Like that's the ultimate, like, evolutionary pressure.
I was just going to say almost exactly the same thing, that regardless of what the organism is, it's in its environment and it needs to figure out how to navigate the environment. And the only way it's going to do that is through its affordances. So whatever organism we're talking about, it has figured out how to detect them. So that might mean that you're a star-nosed mole and you have developed a little thing on your nose like that can detect vibrations with such sensitivity that you can see the rocks in the ground around you, or you're a shark that creates an electrical field around it, and you can sense when things interfere with your electrical field so that you know what you can move through and around and where you want to dig and actually, I don't know what star-nosed moles eat, but maybe like worms.
Star-nosed mole food.
Whatever that food is, they can crawl in the direction of it because they can sense where it is and that it affords eating. And and the diffusia can figure out exactly what grains of sand would make for a good castle.
Affordances is another way to think about it. Affordances are important because you have stuff to do. And affordances are how you do those
You're
things.
gonna do your stuff. That's right.
You got stuff to do.
That's right.
You've got places to go. Well, how do you get there? Affordances will tell you.
Affordances will
Right?
tell you.
You've got water to drink.
Yep. Good thing I can pick up that glass then.
Good thing.
Yeah.
Right? You've got stairs to climb.
Good thing I can climb them then.
Yeah, so it allows that perceiving affordances is much more important in your daily life than perceiving centimeters, perceiving angles,
Or
perceiving
shape or mass or any of those other things.
Again, that's not to say you can't do those things.
But it's not what we do.
And again, to your point, because it's so much more important, doesn't that make so much more sense that we're so much better at it?
Because we are. Because we're so good at it.
Well, and
We're so good at this.
this
It's
is,
our job.
sorry to interrupt.
No,
This
fine.
is another challenge. This is, I think, this is yet another challenge for the more traditional perspective. Not only are they a challenge on this side, on the side of where the knowledge comes from, how it gets built, given that the stimulation is bad, then how do you generate a movement if what you've got is like a mental representation? You've got to somehow work in reverse to put that back into the world.
Right.
And the ecological approach, because perceiving and acting are together,
It's all one thing.
You are perceiving the world in units of action.
Mm-hmm.
And so there's no input translating output. You are perceiving that problem of what's 2 inches to the left of the hole is a non-problem, right? That's the unsolvable mystery. But the scientific problem is how the patterns in light are informative about how to move my body in such a way that this is another. I'm going to go back to Michael Turvey. We had a session honoring Michael at this conference, and so he deserves to be mentioned here. One of his most famous quotes, I think, is what we study is how light gets into the muscle.
Mm-hmm.
And if you think about it that way, not how light gets into the brain, mind you, right? That's probably a more traditional approach, but how light gets into the muscle. And when you think about that, if the light light isn't really coming in, but if we're sensitive to the light in a way that enables us to move, that's a very different problem than it being sensitive to the light in a way that allows us to generate a representation that then allows us to issue the appropriate motor commands in the right sequence and the right timing to generate the muscle movements to do the things you want to do.
And the other thing about that sort of classical view is that it's a two-step process, right? So you first perceive the world, and then you create a motor program from that allows you to then interact with the world. Whereas in the ecological view, these things are continuous with each other. So one of my favorite Gibson quotes that I'm probably going to misquote here is, we act so as to move, we move so as to act. No, wait. We act so as to perceive, we perceive so as to act. I'm fine. and right, so the idea is that, so I want to see whether or not I can pick up that glass, or I'm thirsty, right? So first, I'm not just like looking at my world for no reason. I'm looking for a glass of water to drink. I'm looking for the affordance of drinkable. I'm not just going out into the world and stumbling upon things. I'm looking for something. My action of moving around is going to give me information that I need to know that I can pick up that glass, and that movement is what's going to pick up the glass. So all of that is one continuous event. It's not, I did this first, and then I did this, and then maybe I missed and I had to error correct. No, it's all online. It's all continuous.
The another thing that comes to mind is that in a more traditional perspective, because it's a very incremental, sequential process, the timing gets really messed up, right? Because it takes time to do all these things, and by the time the motor command gets issued and kicked back out again, you're behind.
Yeah, that's right.
And so, but if perceiving is about what can happen, what might happen, and perceiving is acting, then you never need to catch back up. You're always ahead. I mean, what you're really doing and behaving is turning a current state of affairs into an intended state of affairs. I want to reach this glass. Okay, well, so I just need to move my body in such a way that this relationship becomes that relationship.
And notice that there's a third thing here that we've been saying all along without naming, which is the thinking part of that, the cognizing, right? So the book that we're here interviewing about is perceiving, acting, and cognizing for a reason, because that is also continuous with. So I want a glass of water, right? That's a cognitive. That's a thing that a traditional cognitivist would say is like as a representation of a hormonal whatever, blah blah blah, right? but it's a constraint on my behavior that is making it so that I'm seeking out water. That is part of the behavior. That is part of me perceiving the water. These are all part of one thing. To try and separate them out is to try and take things out of their context. And you simply cannot understand those things independent of the context that houses them, right? You can't understand us independent of our context. You can't understand those things independent of their context. It's just not possible. This is why our field is named what it is, right? It's named ecological psychology because it's about the ecology. It's about putting things back into the context, right? Back into the context in which we evolved. We didn't evolve to measure things. We evolved to see, can I hide in that, right? And not get eaten.
And that is the third component of the ecological approach. We've covered two of them. One is the lawful structuring of stimulation patterns or energy patterns. The other one is affordances. And the third one is perceptual systems. This idea that perceptual systems are totally different than sense organs. And one thing perceptual systems do is they are active. They are explore. They obtain rather than receive. And so and they'll explore differently depending on intention. So the intention, the cognitive part is all wrapped in, and critically, it's wrapped into movement. So it's not a thinking body that then sort of directs. It's the intention constrains the movement, which at the moment is for the purpose of perceiving, but then it sort of rolls over into acting.
Yeah, it's all one thing. And you also you said it in there, and I just sort of want to pull it out and highlight it, that you can't think of, when we talk about seeing, you think about the eye, but it's not, the eye isn't the only part of the visual system, right? I want to look at Jeff. I'm not just going to move my eyes over there. I'm going to move my whole body, neck, body system to look over at Jeff. I want to look back at you. I'm going to move that. If I wanted to go see something that was downstairs, it would involve my whole body because I'd have to walk down there to do it. So my visual system is all of me. My auditory system is all of me. So trying to limit it to just the retina on the back of the eye is just nonsense. It's just nonsense.
Even better than that, or in addition to that, maybe that's not better.
And also, but also.
Wait. Yes, and, right?
Yeah, that's it. Yes, and.
Yes, and. Yes, and.
And.
It also includes things that are attached or connected to you. I tell students that you're looking with binoculars, that becomes part of your visual system too. You are perceiving the world by tapping it with a stick, part of your touch system. These things can be, it's just like, in the same way that affordances are amorphous and they change with activity, so do your perceptual systems.
Yes.
It's a very strange way to think about the body. And this is what I meant before when I said just because something can do something or does something doesn't mean that's what it's for. You walk on your feet, but you could also crawl. I mean, so your feet, you might say, what are your feet for? Well, they're for walking, but also lots of other things.
Also lots of other things.
Your hands are for manipulating objects, but they can also help you hear better. These are, so trying to get away from closely linking anatomy to function, getting away from trying to see it more as a relationship between animal and environment by means of behavior of the body.
I want to expand on the thing you said about the using a stick to perceive. When I teach this, I always have my students, back when they used paper and pencils to take notes, some of them still do. But anyway, you have them close their eyes and put the pencil down on the paper and then run the paper across to the, the pencil across and feel your desk, right? And you have this feeling of sensing the desk directly, because this is what you're doing, right? But you're doing it with the pencil, which has no sense organs. It has no mechanoreceptors in it, right? Just what we talk about when we talk about sensing things with your hands. So you got none of those little sense organs sending anything to your brain. And yet you feel as though you were feeling with the tip of the pencil. You can probe the world in that way, right? So I encourage the people listening to this podcast, try yourself. Pick out a pencil and just use that pencil to close your eyes and use the pencil to explore. And you will feel like you are exploring with the tip of the pencil, not with your hand, but with this thing that has now become part of your touch system, right? It's now part of you. And that's also why we are very clear that you can't really, just like we're saying, the mind really can't be separate from the body because you run into problems. The animal really can't, or organism cannot really be separated from its environment because you run into problems pretty fast. This is another example of that. Where is the line between me and the environment if I can sense the table with my pencil? You know? Yeah.
Love it. Well, that's such a great example too, because it's just so.
Right? You think about it, right? Just
it doesn't make sense, you know. Like
you can
from
feel,
that
oh, there's your
normal-
book, there's your book.
Yes.
Now I'm on the table again, right?
It's really not all that different from how your other perceptual experiences work, right? This is the difference between stimulation. We talk about it doesn't, the stimulation itself is not what's important. My retinas are stimulated here, but I perceive you there. And that for centuries, that was a confounding philosophical problem called the outness problem. Why in the world would I experience the world out there when my nervous system is being tickled in here? Same thing happens with hearing, right? It's like these little vibrations are happening on this tiny, tiny, tiny like piece of membrane, but yet it's all
hear it
around
out there.
me.
Yeah.
But it's not a problem if we focus instead on the structured stimulation, because that's lawfully
happening out there.
related to the surface layout.
Yes. It's nice working with the same person for years. You develop a
Yeah,
shorthand,
guys
you know.
You guys got quite the rapport going.
I mean, we've been working together on things for what, 7, 8 years now? 7?
Well, the first book came out in 2020.
And then we worked on it for a while before then, because I was working on it back at my old job. And then, and it's just the more time we spend together, the easier those things get, and you start realizing the ways in which your skills are complementary, and really it's a good working relationship for that. So
We've talked about the animal environment symmetry.
That's right.
There's a Jeff and Julia.
There's a Jeff and Julia symmetry here as well. That's right. Anyway, sorry, you had more questions.
Yeah, I did want to talk about that at some point too, actually.
Yeah.
So
should we tell the people why we're back outside now? Like, hey, we're outside.
no,
Don't be alarmed.
Skip it. So with the cognizing part, so there's this thing you guys explain in the book, right? Of this
central executive.
Central
executive,
Yes.
right? That is doing this unconscious inference. He's fixing the bad. He's making a representation. He's fixing the bad stimulus.
Yeah.
And,
all without you knowing about it.
Right.
Yep.
And now, but I guess the part that it's so different from how I've always thought about it is that cognition. I'm going to go do. I make a decision.
Yeah.
I'm going to do this.
Yep.
Right.
Yep.
And then, so I understand there's this idea of nonlinear causality, and maybe how that fixes. I guess it's that decision-making process.
The
right?
problem is it's a very compelling feeling, right? That the I that is I, right? I'm sitting behind my eyes that belong to me somehow, and I'm somehow separate from them, right? It's a very compelling feeling, which is part of the reason why I think that dualism has persisted for so long, right? Is because it is a really compelling feeling. I mean, it's in our language, right? We talk about it. This is my hand. It's a thing I own, right? Somehow that is separate from me. And we're not suggesting that you don't have an identity, right? Or that you don't exist as a thing. Of course you do. It's just that is not fundamentally different from your hand, right? It's all a part of the same thing. This thing that we feel as consciousness is an emergent property of the way that our body does its thing, right?
This is part of what makes Gibson's theory so revolutionary, is not just because he was reacting to behaviorism and cognitivism, he was reacting to hundreds, if not thousands of years of these assumptions, like our mind is separate from our body,
Right.
like the animal is separate from the environment. And so, yeah, those are underlying the behaviorist and cognitivist ideas. Those are
Right. They're foundational
that's
too.
where that, and once you change those, then the solutions become obvious. But until you recognize those are the assumptions that you make,
Yeah.
it's really hard. But gosh, I mean, when I talk to students, I really convince them about that there is a separation between mind and body because they buy into it. It
Yeah.
feels like it. I say things like, if I came to you and I said, I had a dream last night and it weighed 4 pounds, they go, you can't, why doesn't that make sense? Well, it doesn't make sense because dreams are these things that are not like, you can't measure them. You can't,
Right.
they aren't like the world, and so a mind-body separation. There's this,
Right.
and you know, let's be honest, there is also a huge religious component to
Right.
this that was also
the
thousands
soul.
of years old.
Before we called it the mind, we called it the soul. When we were Descartes, so it's important to remember that Descartes made this separation not because he genuinely believed there was a separation between the mind and the body. It's because he was working at a time when you couldn't be a scientist who studied the body because the church was like, this belongs to God, and you can't study something that belongs to God. And so he said, no, no, it's fine. It's fine. I'll fix it. See, we have a soul. The soul belongs to God. The body belongs to the earth. It's profane. It's not God's. So I can study it. So he made that separation not necessarily because he really believed in it. And there's some evidence from his journals that he did not. It's so that he could study the body without being, beheaded by the church. And, he was doing a lot of it. It was like grave robbing. He did a lot of whole stuff. But so that separation, though, it's like, because it's so compelling and because it's so old, people even forget that it's an assumption. People even forget that is a thing that is underlying all of this stuff, so that when we say my body, my hand, as if it is a thing I own, you don't even hear it anymore. That what you're saying is these two things are separate.
Yeah,
'cause
whose
this is
else would
something-
it be?
Yeah, whose else would it be? Right? Right. So at any rate, it's the ecological view of this is that which you call your consciousness is an emergent property of your whole organism, right? Which includes things like your hand, right? We tend to limit it to things like the nervous system, but the truth is it's an emergent property of all of those things, right? The same way that you nodding right now is an emergent property of all of the muscles and tendons and bones that you are. It's all the same. It just feels different because you've been told it's different.
Is it an emergent property of an organism in an environment?
Yes.
Has to be.
Has to be. Because you can't exist separate from your environment. You cannot.
So just
Yeah. No, well, I was going to go back. We started with Newtonian physics. You can have an object like a mass
Right.
existing independent of things. You can have
Right.
these things. You can have you can have, I don't know, Newtonian points that are independent of all these other things. But
Right.
we can't. The question was about emergent. Well, nothing emerges without a context.
Without a
right?
context. You got to have the
That's
context.
it's another lesson, not necessarily of ecological psychology, but one that ecological psychology has adopted, and this because it more comes from the dynamical systems perspective, but that is that patterns don't come from nothing.
Yeah.
Patterns come from other patterns. So it's you're never really answering the question of how this structured perceptual experience just occurs. Well, it doesn't just.
It doesn't just occur.
And it's much easier to talk about how this structured pattern turns into or becomes or yields this structured pattern. That is an example of a scientific problem rather than an unsolvable mystery.
Yes.
For the viewers that we haven't actually explained it yet, what is nonlinear causality?
So it helps to, again, explain it in contrasts, right? So direct causality is when you have thing A, or direct or non or local linear causality is where thing A, causes thing B, which causes thing C, which causes thing D, right? Single, unbroken line, simple, right? And we love it. We would love if things were just that simple, right? It's so compelling because we wish things were that simple. But the reality is everything is more complicated than that, right? So you think about what resulted in us having this interview right now in this moment at this space, right? You could say it's because we wrote a book and you're interested, but we wrote a book and other people were interested in too, and we're not interviewing them. You could say it is because the guy kicked us out of the upstairs. See, I'm doing your voiceover for you. And so we had to come down here, right? You could say it is because we are all coming to this conference. All of these things had to be happening in order for this moment to happen here in this. It's not a singular chain of events that led to this. That's a nice, simple, clean story, but it doesn't actually capture our behavior. So to explain something like how we're here in this moment, you have to have more complex causality. And that's going to include things that are nonlinear, right? So to simplify it, so thing A causes thing B, but thing C is involved in this as well. So that if thing A and thing C are there, B is going to happen twice as hard, right? So that's a nonlinear effect where you're getting, it's not just an addition, you're creating a whole new behavior out of it. Did I explain that well? I'm not sure I explained that.
I think so. It has to do with causes that are at some distance
Yes,
from
their effect.
their effect and in disproportion to their effect.
Yeah,
right?
yeah.
Well, see, I have time to think when you're answering the
Ah, see, that's the trick. That's a good trick.
So, the weather in Trondheim varies in the course of a day. Well, why is that? And why can't forecasters just tell you what it's going to do the next day? Damn it! Well, they can, because there are all kinds of things that influence the weather. How the weather was an hour ago, but also how the weather was last week, but also what's happening 1,000 miles away.
Yeah.
All at the same time. And some of those factors are not just simply adding together, they're multiplying, they're exponentially related. And that's nonlinear causality, where you get a faraway cause can disproportionately affect something near. And
It's an old saying, but a butterfly flapping its wings on one side of the earth causes a tornado on the other side. It's true though. Things like that can happen. These small things can have outsized effects when you see the way that they go through a system, right? Because it's not a machine. A machine would be thing A causes thing B causes thing C. A system is everything is interconnected, and so causality isn't going to be simple in a system. It just is never going to be.
How does traditional cognitive psychology think about that? Are they just like, because it especially these days,
Yeah.
it's there, right? It's obvious.
Yeah.
It seems.
So traditional cognitivist is going to think of the body as a machine, right? And so it's going to be context independent, right? A person's going to person in exactly the same way, no matter what context you put them in. This is why you get personality theorists trying to figure out, stable personality traits. But the truth is we act very differently depending on our context. So personality isn't as stable as all of that, right? Like I'm doing a whole interview person right now that is a different person than I am when I'm like in a classroom taking notes, right? I wouldn't be acting like this, or if I was at a party or, at a bar, like you're going to have it different based on those contexts. So anyway, in a machine though, you put a car on this road, it's going to drive. You put a car on that road, it's going to drive. You put a car on that road, it's going to drive. It's going to do the same thing regardless of the context. And that's very compelling as a scientist. If you want to explain human behavior, you want it to be simple and context independent because that's easy. And so we've conceptualized as people as machines, organisms as machines for a very long time, since Descartes and before, because it's simple and it's easy, but it is also incorrect. It doesn't get you there.
And I think the way that that has been handled in a lot of traditional approaches is just to put another component in the equation.
Right.
Like we need another.
Add another piece to the machine.
Yeah, or another part to the computational processes that handles the additional context.
Yeah.
That this is the, I can't think of it, but this is the, we need another variable. Like in the inner workings of the processes that move the machine, we need to add this variable that accounts for the process.
Yeah.
So I think there's a respecting of process. There's a realization that, or there's a respecting of context.
But it's just another cog.
Yeah.
Rather than vital to the whole system.
Or let's make the machine. Let's make the machine responsive to context, but that's a little bit different than having context part of
inextricable.
Yeah, of the process.
Yeah.
I think one of the most striking things about the book is how accessible you guys made it.
Thank you.
And
that was the goal.
and that's a feat,
yeah.
Right? Especially with the complexity, especially when we're talking about like
complexity. It's really hard.
And so, can you talk a little bit about?
Yeah. So before we ever started writing, I mean, I think we spent easily a couple of months talking about the tone. What is going to be the tone of the book? How are we going to go about doing this? And the story I always tell about this, which is true, is that I wanted to make something where I could hand it to my mom, who's a intelligent woman who knows nothing about my field, right? She's smart, she's educated, she knows stuff, but she knows nothing from psychology. She's an artist, right? I wanted to be able to hand her the book, and so she would finally understand what I do for a living, right? That she could read it, that it would be fun for her to read, that it would be engaging and interesting. And by the end of it, she would know why I do what I do. That was the idea. And so we would write these sections, and in these chapters, we'd send them back and forth for notes. And the most common note we gave each other was, this needs momming up. Mom would be confused here, because we're always trying to make it just more accessible, more accessible. This is why we have the little character Fred that's through the whole book, is to make it accessible. I find that when you make things concrete, and he's got a whole personality now, and based on this book, so it was the fundamental goal was to make it something that people outside of our field, people outside of psychology, would pick up and read. And we were talking about this earlier, this idea that this feels, to me at least, and I think to many of us, as a unifying theory of psychology. The same way you've got the unified theory of physics, right? We're going to get unified theory of psychology. All of the human behavior is explainable using these concepts. So we need to be able to go to somebody who doesn't know anything from perception and doesn't care, and say, look, here's a tool, and it will matter to you in clinical psychology. It will matter to you in movement science and how we do fighting in MMA. It'll matter to you over there in your social psychology and how you imagine groups interacting in a dynamic way.
It was even a talk today suggesting that we can take the concepts from ecological psychology and better understand physics and our time, right? So we can go the other direction.
Yeah.
So not just understand psychology, but just spread out.
But everything a little better.
Because part of the reason is that it is aligned with other sciences. It's a way, and there are scientists who think, with good reason, that, so let me back up. We sometimes think that animals are exceptions. And so we have laws, we describe laws of the universe in the absence of living things, which are Newtonian physics and Euclidean geometry. And then we put animals in there and we say, okay.
They're different though.
Yeah.
But they're different.
And so the animals or the living things, the laws that describe them are the exceptions. They're much more specific.
Well,
and
humans are even more special than that. We're more special and differenter.
There's a way of thinking about things that the laws that describe living things are actually more general.
Yeah.
And the system that has no living things is the exception. That's really that really blew my mind when I first thought about that.
Yeah.
Because it makes
That's
it so that
Rosen.
you don't
Good
need.
stuff.
Yes, that's right. You don't need to. You don't need to add to theories of non-living systems to get living systems. You can start the other way around. You can work your way down instead of working your way up, which is I mean,
Yeah.
you know, up and down are all relative, but it just provides a way to.
But that unifying framework
Yeah.
might be useful to people other than just us. And us who is specialized into this special, thing that we study. Not special, but in the way that all science is special and all the way that all study is like I'm looking at this tiny little piece of much bigger, but that this framework would be useful to many, and so we need to be able to give a book that can be given to any.
Oh wow, that's where we started. Was with this book.
So you remember?
Yeah.
I brought you back to the question.
Right.
Remember the question?
Thank you.
Yeah.
So we used Julia's mom, but everybody's mom as
Everybody's
a model.
mom.
The other thing we did is that
Or everybody's brother or sister or,
Whoever.
neighbor. Anybody who might have a thing they're interested in. Oh, well, have you considered that thing you're interested in from this perspective?
the other thing we tried to do was fill a niche. That James Gibson was the person who developed the ecological approach,
Right.
did so over 50 years of a career,
Right.
and the last book he wrote was accessible, but he said things in a very folksy way that created a whole lot of debate.
Which is good.
And then people tried to really get that folksy language down to it's the most technical and to really nail down the technicalities. And so then that was Mike Turvey, Bob Shaw, Bill Mace, and they wrote a series of books that are all at this level. So
And that are very hard as your first introduction.
So you either read Gibson, which is like, okay, I
Folksy,
sort of see
but
this, or you read these, which is they're
inaccessible.
well
To people to a layperson.
Yes.
Completely inaccessible to a layperson.
And so we thought, well, let's try and go here.
Yeah, there's got to be a thing in
Let's
between.
try and go here so that we're a little bit more technical, maybe, than Gibson, a little more accessible than some of those big, deep theory papers.
So that you can have a framework to better understand some of those deeper theory papers if you wanted to go in that direction. But that you could also just have the framework and then apply it to something that you liked, right? Which is what we're finding. I mean, we're getting emails and phone calls and stuff from all over the world of people who are saying, oh, I design video games and I've been thinking a lot about this theory and I'd like to apply it to that. And I love that. I love that that's what it's doing. That was the goal. My mother still hasn't read it. So I'm sure any day now. She's read chapters, but not the whole thing. We'll get there.
I do the same thing, by the way. I all my videos I send to my mom, and it's
one of these days.
I love that that's a common strategy.
That's right. If you get it, then we're fine.
Absolutely.
All right.
So, last big question.
All right.
Why has this not become a bigger field?
That's a really
It
good
is a
question.
good question. I think it's a couple of things. For one thing, I think people underestimate how hard a paradigm shift is. Because in a paradigm shift, you are not just making an adjustment to something that already exists, right? So somebody gave up the example of the cognitive revolution, but the cognitive revolution was just making an adjustment to the idea of the mind-body and saying, the mind works in this way. It wasn't challenging those fundamental assumptions. Challenging fundamental assumptions is hard because you have to say to somebody, the world you think you're living in? Not so much, actually. You're living in a completely different world. You're going to need to start over because everything you know is wrong. That's really hard. And it's a unusual person that is capable of doing that is capable of saying, I'm going to toss out everything that I've learned and start over completely like I'm a middle schooler back in science class for the first time. So you're really not aiming at those people. You're not aiming at the people who are established scientists because, like I said, it's a really unusual person who could do that. I don't think I could do it at this point. So you kind of have to wait for them to die. And in the meantime, you have to reach out to people who haven't started learning this yet. And I think we're doing a very good job of waiting around for people to die. We're not necessarily doing the very best job of reaching out to the people who haven't learned it yet. And this book is our first attempt at that. We're currently writing another book, which is a sensation and perception textbook, which will be another in that same idea, sort of a different crowd, right? This is more of a book that could be picked up by anybody, right? Where the sensation and perception textbook is meant for an undergraduate studying sensation and perception for the first time. And and we're doing things like this, doing podcasts, trying to reach out to people maybe who have never thought about these things before, so now they can think about it our way. But paradigm shifts take forever. I mean, the heliocentric revolution, 100 years.
The reason why
100
that
years.
stuck around is because it was
It
successful.
worked better.
Well, no, I'm talking about the geocentric.
Oh, yes.
Yeah,
It
so
was very,
that stuck around because it was successful.
Yeah.
It explained
a lot.
and that's why the traditional perspective on perceiving and acting and thinking is
Still around.
because
It explains a lot.
it's really, you're trying to get people to change their minds on something that kind of works, and
Yeah.
it's just like, why would they change their mind? It kind of works.
kinda
Like,
works.
you've got this car that kind of gets you from place to place, and we're saying, but there's a better car. You're like, but I got a car.
But I got a
car.
Yeah.
I don't I'm already halfway gone. Like, I don't want, you're back there. I don't want to
Yeah.
go get your car.
Yeah.
I don't.
No, I think exactly so. And you're asking people to give up on, something that's working. It just isn't working enough. Much like the geocentric view worked, but it wasn't working enough. And so I think it's a many-fold problem, but I genuinely believe that if we continue to show people this, more and more you convince people, because it just makes more sense, the truth will out. That's how I feel.
Are you guys familiar with different keyboard layouts? Dvorak?
You mean like QWERTY versus, yeah. Although my understanding of that research is it turns out good typists are good typists. It doesn't matter what keyboard you put them on anymore. Am I misremembering the literature?
No.
Why are we talking about it? Why'd you bring it up?
Hold on.
So you probably know more about this. I don't know, maybe you know more about this than I do, but my take on it was that QWERTY is pretty much a random keyboard layout. Like, it's an artifact of typewriting.
Mm-hmm.
And so, as it started becoming more and more common,
Right.
some guys started going, hey,
And it caught steam.
let's make this more
Yeah.
efficient. Like, let's really think about where are we gonna place these keys.
Oh, I remember this. And he put together a more efficient for what you actually do keyboard, and no one will use it. And no one will use it.
No one ever, it never achieved until now, and it could in the future.
Who knows?
But
You
We'll
could.
advertise it right here. but because this is what I'm used to and it works, and I have to write a paper today. I don't have time to learn your new keyboard because I have to write a paper today. It works.
It's like electric cars. I was just thinking about this. Like,
Sure.
We've had gas-powered cars for 100 years, and they work, and they have there's advantages to using it. And, electric cars are expensive, and you got to get an electric jack installed. And
Yeah.
But we're like, but there's like good reasons, and maybe everyone should have one. And, so there's it's
Overcoming inertia is a real thing.
it really is. We're trying to do hearts and minds. I always describe whoever is like the hot like third party or like candidate in American elections, and I'm like, that's who ecological psychology was. Years ago, like I was in the last election, few election cycles ago, I was like, we are like Bernie Sanders, right?
No, we don't want to get political.
No, because Bernie Sanders had a strong following. A lot of people agree with him, but he wasn't.
Because it wasn't the established
He
way
wasn't
of doing
the
it. So it's not
established
the
way of
QWERTY
doing
keyboard of
things.
it. Yeah, he's the Dvorak keyboard of the. Anyway.
Amazing. So where can people find out about your book? Where can they get it?
So the book is currently available on the Routledge website, but you can also get it on Amazon. And actually, very shortly, I will be going into the studio to record an audiobook version. So
Very
look for
exciting.
that on anywhere they sell audiobooks. And then also, we're going to be coming out with a new edition at some point, which shouldn't stop people from buying this edition. But we will be doing that, eventually in maybe a couple of years. So, but yeah, Routledge website and Amazon are the places I know. I think you can buy it in like a used bookstore too. Yeah.
Perfect.
Thank you.
I got it on Amazon.
It's a good place. That's where I get everything. Probably shouldn't do that, but I do. All right. Well, thank you so much for
Thank you,
interviewing us
guys.
today. This
Yeah,
was
this
great.
was
This was a lot of fun.
And also, I think, as far as, hearts and minds.
Hearts and minds.
I think, for me, things like this are
A big way to do
where
it.
yeah, especially, again, like you guys made such an accessible book, right? And now we have such an accessible interview. And,
That's the goal.
hopefully those things, and then now that's freely accessible on the internet.
Yeah.
And when these things really start to work together, and then at a fundamental level, we have a more compelling scientific theory.
I agree.
I think.
Sounds like a synergy to me.
Yeah.
No nerd jokes.
Oh.
Nerd jokes.
You still have nerd jokes.
I love a nerd joke. I think the general population is interested in science so long as you make it interesting. Like
Exactly.
science doesn't have to be boring in order to be rigorous.
Yes.
Science can be fun.
I absolutely agree.
Thanks again to Julia and Jeff for making time to sit down and talk with me during a busy conference. I can honestly say their book is the best textbook I've ever read. And if you want to dig into it and support this channel at the same time, there's a link in the description. Subscribe.